welcome to all you beautiful mind-setters. We are tuned into the Grade 10 Mathematics Show with myself, Queen Matoso. But of course, as always, I am not alone. I've got the lovely teacher, Natasha. How are you, Natasha?
I'm very well, thanks, Queen. Great to see you again on a Monday.
Great to see you too. Now, guys, remember that we are in the second round of our Sony Xperia competition. So all you have to do is always remember that you must register on Curio, and then we have 6 more teachers that you guys can choose. And if you have a favorite teacher on the 6 that we've posted up, all you have to do is simply like that teacher and then come onto our Facebook page and also like the teacher's photo on our Facebook page. And also, guys, remember to share the picture of the competition on our Facebook page in order to stand yourself a chance to win that beautiful Sony Xperia L. Or you can also get to win yourself 55 Rand Vodacom airtime. It is #GetConnected. Don't forget, get those things clicking. And we've also got a beautiful competition of our Casio calculator. All you have to do is simply answer the test yourself answers correctly, and you can stand a chance to win yourself this awesome Casio calculator. Now, that is enough said. I'm sure I've said a lot. Let's get straight into the show. Natasha, what do you have for us today?
All right, guys. Well, grade 10, today we're looking at statistics, and we're going to be covering quite a lot in statistics. We're going to look at measures of central tendency. We're also going to look at measures of dispersion, and we're going to do the box and whisker diagram as well. So, Queen, can we get straight into it?
Let's do it.
All right. Okay, a reminder of your challenge question for today. Lesego wants a mean mark, remember mean is the same as average, of at least 70% for math. If she writes 6 tests in total and gets a mean mark of 61% for the first 5 tests, what is the minimum mark that she must get in the 6th test to get a mean mark of at least 70% overall? All right, based on your answer, this is part B, will she be able to get 70% for the year? Okay, guys, have a look at that, and hopefully by the time we get to the end of today's lesson, you will be able to answer that. Now, before we go straight diving into the questions, we're going to have a quick look at the summary of some of the terms you guys need to be aware of. All right, when we talk about statistics, we are dealing with collecting, organizing, representing, and interpreting data. Representing, remember, you can use your charts or your graphs and so on to represent your data, and then you then look at that and interpret. A reminder of your terms, as I said, quantitative data is numerical data that can be counted or measured. Now, when we're talking about counting data or measuring data, we've got 2 different terminologies that we use there. We call discrete data, that's data that are quantitative data obtained by counting. Okay, an example here would be the number of you guys that are watching the show right now, or the number of you that like our Facebook page or our competitions, etc. When we're looking at continuous data, and guys, you'll notice that we always say data are, and it sounds kind of odd, but it is correct. It is grammatically correct, because remember, when you're dealing with data, you're looking at a whole bunch of different values in that. So you can't say data is, you've got to say data are. So continuous data are quantitative data that's obtained by measuring. Here you're using tape measures, scales, etc. And an example here will be your height or your weight. So that was quantitative data, which is numerical data. Qualitative data is data that cannot be written as numbers, okay? These are then divided into 2 categories. We get categorical data, and an example here will be your favorite cool drink, the color of your cell phone, eyes, etc., or your home language. Then you get anecdotal data. All right, and this is, for example, if you think of an interview or a story, or maybe someone's doing a bit of market research and they ask you questions like things like, what was your personal experience when using a certain hair product, and that kind of thing. All right. Ungrouped data is also called raw data. This data has not been organized in any way at all. So it's just a list of data. Nothing's been done to organize that data. And then grouped data, as it suggests, is both your discrete and continuous data that can be grouped using a frequency table. Now, important here to note is that you do use different formulae depending on whether you're working with grouped data or ungrouped data. So there's different formulae you need to use for each of those when working out your measures of central tendency. And you've got to just keep in mind when you're looking at your question, are you dealing with grouped data or are you dealing with ungrouped data? Okay, so speaking about measures of central tendency, just a reminder of what we are talking about there. There's three different types of measures of central tendency. First, we'll look at the mean. The mean is also known as the average, and it's the sum of a set of values divided by the number of values in the set. All right. And what you'll notice with your formulae is when we talk about the sum, well, really throughout maths, but specifically in stats, we use sigma, which is a Greek letter representing the sum. So if we're looking at the mean, we're going to say it's the sum of all the x values divided by the number of values in the data set. And we say that's equal to the mean, which we write as x bar. All right? The median is the value in the exact central position. In order to work out your median, very importantly, the data set has to be arranged from the lowest to the highest. So from your minimum to your maximum value. And what happens with your median is that exactly half of the values are less than whatever the median is, and then the other half will be greater than the median. Your mode, it's the value of a data set that will occur most frequently, and it's the most common value of the set. It is quite useful when, especially in market research, people are asking you what's your favorite cool drink, etc. They can get an idea of what product people respond to quite well. Okay, just a little notes on our mean, median, and mode. With the mean, remember you were using all of the values in your data set in order to work out your mean. And what that then implies is that your mean will be affected by any outliers. Outliers, remember, are like extremely high or extremely low values. So if you think of in a class test, you might get a mean, the class average is 60%, but you have one student, who's just so smart and they get 99% for every test, and you'll find that your mean mark for the class is then skewed towards the higher end because someone is taking the greater burden of getting really, really good marks. So your mean can be influenced, or will always be influenced, by outliers. So that's something to bear in mind when you deal with the mean. Your median is not affected by outliers. Whatever value is in the central position will remain in the central position. And your mode is something that, as I said, it will occur when there's repeated values. However, if there are no repeated values, you will not get a mode. It is possible to not have a mode in a specific data set. All right, moving on to measures of dispersion. Now, dispersion is just a general term for different statistics that describe how values are distributed around the center value around your measures of central tendency. Okay? Your range of a data set is the difference between the maximum and minimum values in the set. Now, while we're on this point here, when you're looking at grouped data, it's not possible to find a range because remember your group data has been arranged into class intervals, and it's not possible to then work out your range for your grouped data. Okay, so just bear that point in mind. Your quartiles, those are the three different data values that will divide an ordered data set into 4 equal groups, okay? Where each group contains an equal number of data values, as I said. The median, also called the 50th percentile. Let's have a look at the word percentile. So we know that quartiles, as the name implies, divides your data set into 4s. And percentiles, by implication, percentile coming from percent, will divide your group into hundredths. It will divide your data set into sets of 100ths. Okay, so your median is also called the 50th percentile. It's also called your second quartile. all right? The 25th percentile is also called the first or lower quartile. So what we're saying is Q1 is equivalent to the 25th percentile. All right? And the 75th percentile, similarly, is the third or upper quartile. Okay, we will deal with that in more detail when we look at some of the questions. The 5-number summary consists of the minimum value, the maximum value, and the 3 quartiles. So it gives you a quick overview of what's happening in your data set. The box and whisker plot is a graphical representation of the 5-number summary, and I'm just going to do a rough diagram here. So this would be our little rectangular box. The first end here of the rectangle will be at the lower quartile. The upper end will be at the upper quartile, and then somewhere in between there you would have worked out your second quartile or your median. All right, and then at the edges of the boxes you will have 2 whiskers drawn out, and they will take you to your minimum value and your maximum values of your data set. Okay, so that's roughly what a box and whisker plot or a box and whisker diagram is going to look like, and we will have a look at that when we do some examples. But before we get stuck into the examples, it's quite a lot of information for you guys to digest, so I think this will be a good point for us to take a quick break and then come back and continue with questions.
All right, before we take the quick ad break, guys, remember, we're still continuing with our competition to win yourself a Sony Xperia cell phone or airtime. And because we are in the second round of the competition, we will be announcing the first round's winner. So mindsetters, stay tuned. Do not go anywhere. We will be announcing the winner at 6 o'clock today. Let's take a quick ad break. I'm sure you guys just want to go refresh yourselves quickly, and then we'll continue after the break. Welcome back, Mindsetters. I hope you guys have yourselves ready and refreshed from the break. Now, I can see that the grade 10s are actually on a roll with the challenge question, Natasha. Guys, remember that we also have the test yourself questions in order to win yourself this awesome Casio calculator. And we will still be announcing our previous winner of the Casio calculator. But Natasha, let's get straight into business.
All right, guys, so we've got quite a lot to cover. We've talked about a lot of terms, but obviously stats is all about how you apply those and how you interpret the values that you get from working out your different measures of dispersion or your measures of central tendency. So with that in mind, let's look at question 1. Okay, you were given marks in percentage form for a group of learners. And the first thing you would need to do is when you look at that data, before you look at the questions and that, just look at it yourself and decide, well, what kind of data is this? Is it grouped? Is it ungrouped? Is it discrete? Is it continuous? You know, start asking yourself questions about the data so that when you start looking at the actual questions that they've asked you, you have an idea of where to go with this whole where you can go with the answering the question. Okay, so we've got an entire set of data. First thing you should do, as I say, analyze that data. If you count the number of entries there, you'll see that there are 34 different marks. It is ungrouped because all the data is just given to you in this form. No grouping has been done with it at all. Is it, part A, discrete or continuous? Now remember, in order to answer this, you'll need to remember that discrete data can be counted and continuous data has to be measured. So here we can clearly count the data, so therefore it will be, our answer here will be discrete data. All right? Part B, find the median, the lower and upper quartiles and the interquartile range. Okay, before we can answer the question, Part B. The first thing you guys will need to do is you take your 34 marks and you need to order them. You order them from smallest to biggest value, and then we're going to determine by looking, once we've got our order data set, we're going to then look at our values and determine our median, which remember is the centermost number, and then we're going to find our lower and upper quartiles and the interquartile range, which is the difference between the upper quartile and the lower quartile. Okay, so we've already arranged the data in ascending order, so from the lowest mark, which is 55, to your highest mark, which was 100. Okay, when we're looking for the median, remember it's the value that's in the centermost position. So we know that we're dealing with 34, which is an even number, 34 marks. So therefore, our median will be in the position between the 17th and 18th values. How did I get that? Well, 34 is an even number. If I take 34 and divide it by 2, I get 17. But it's not possible, if you look at your data and you order it, it's not possible to just have 75 as the middlemost numbers, because there'll be more numbers to the left or more numbers to the right than there are to the other side. So what you do is you then locate the position of the median as between the 17th and 18th value, all right, and you find what is the average of those two values. Okay, so we count, we've got 34. When you get to this point here, 75, that's your second 75, that's your 17th value, all right, so therefore the 75 next to it will be your 18th value. So what that implies is that our median is going to be between those two values. It's going to sit somewhere in between there, all right? So in order to find the median when it's between two values, you find the average. So it's 75 plus 75, so this is our median. 75 plus 75 divided by 2, which is 150 divided by 2, which gives me 75. All right, so therefore our median is 75, and it's located between the 17th and 18th data points. Okay. The next thing they wanted to do was to find the lower and upper quartiles. Now, once you've located your median, okay, we know it's in this position here. Your lower quartile, which is Q1, is actually the median. Okay, so Q1, to find Q1, it's the median of the lower half of your values. All right, so that means we're looking to the left of this, and we're finding the median of all of those values. All right, then in order to find Q3, you work out the median of the upper half of values. Okay, so then we go from the median point and we look to the right. Okay, we're going to find the median of the upper half and the lower half in order to get Q1 and then Q3. All right, so we know that there are 17 points up to this number here, 75. All right, so my median is then going to be in position. Let's have a look. Remember, when you're dealing with your median, it's actually going to then divide your lower half. We're looking for the median of the lower half of values. All right, so what it's going to do is it's going to take the lower half of values and it's going to divide those 17 points in 2. Okay, so let's have a look. Let's count with this and let's see where we get to. So there we've got 1, 2, 3, 4, 5, 6, 7. Okay, and that's 8 values up to there. And then if we go from there onwards, we've got 1. Let's take a different color. 1, 2, 3, 4, 5, 6, 7, 8 values. And 9 values up to 75. Now, if you need to divide your data set so that you get your centralmost number, okay, we're looking at 17. We divide that by 2. And what do we get there? 17 divided by 2, that's about 8.5. Let's just check. My mental maths is failing me. 8.5. There we go. So that means that your median is going to be in position 9. So let's count again. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And let's look at the number of values below the 65 and then the number of values above that 65. Okay, so here I've got 1, 2, 3, 4, 5, 6, 7, 8 values. And then there's my median of the lower half, right? So therefore there should be 8 values to the right. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this median point, 65, divides your lower half into 2 equal pieces. So therefore Q1 is going to be equal to 65. All right, and then Q3 we do exactly the same thing. All right, again there's going to be 17 sets of data to the right of our median, which was initially 75. So we know there's 17 sets, 17 pieces of data to the right of that. And again, you can do the same thing. 9 positions away from here is going to be your median of the upper half of data. So in other words, your Q3. Okay. Right, so let's have a count. So there's our 75. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that one falls into position 9. Okay, and then we've got 1, 2, 3, 4, 5, 6, 7, 8. So this value of 85 divides your upper half of values into 2 equal pieces. Okay, so therefore what you've got here, if you have a look, you've got 1 there, our lower quartile. We worked out before our median, and now we've just worked out our Q1, our upper quartile. So therefore we've got the 3 values that divide this entire 34 pieces of data into 4 equal pieces. All right, so our Q3, our upper quartile, will be 85. Okay, so Q3 is 85. Now, what does this all mean? And I'm just going to erase this and leave the important pieces on so that we can investigate this a little bit further. So we've worked out median, we've worked out the lower quartile, we worked out the upper quartile. But what do these values actually tell us? Okay, so remember our lower quartile was 65, and we got our upper quartile as 85, and our median was here of 75. So what that tells us is that with the lower quartile of 65, it means that 25% of your values will be less than 65%. All right, so 25% of values lie between 55 and 65. The median, which was here at 75%, that tells us that exactly half of your values will be less than 75% and the other half will be greater than 75. I'm talking about the mark 75. All right, and then our upper quartile, which is Q3, tells us that 75% of values or 75% of marks is less than 85%, which implies that 25% must be greater than the mark of 85%. All right. Okay, guys, so it just takes a little bit of practice to get used to working out your lower and your upper quartiles and working out your medians. But remember, the key is when you've got just a list of numbers that are given to you and you've got discrete data, you have to first order that data before you can work out your median, and then before you can work out your lower quartile and your upper quartile, and our interquartile range, which is the difference between the upper and lower quartiles. Let's have a look at that one. So to work out our interquartile range, we say Q3 minus Q1. And remember, this value tells you by how much the middle of the data differs. All right. So they differ generally by about 20%. Okay, so we say 85% minus 65, and that gives us an interquartile range of 20%. Now let's have a look at the last part, part C. They say find the 80th percentile and explain what it tells us about the marks. So your 80th percentile, remember, it's dividing your data into hundredths, and therefore you get 99 percentiles. If I want the position of the 80th percentile, I simply take 80th percentile, so 80 divided by 100 gives me 0.8, times that by the number of values in your data set. So we say 0.8 times 34, and that gives us 27.2. So therefore, your 80th percentile will lie in approximately position 27. So we go to our data, all right, and we look at what number is in the 27th position. Now remember, up to here, that was 17, so let's count. That's 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, and we end up on this one here, 85%. Okay. What does this tell us? Because remember, this is the 80th percentile. So the 80th percentile is equal to 85%. Okay. What that tells you is that 80% of your marks were actually lower than 85%. So 80% of your marks were lower than 85%. Therefore, 20%, which is the remaining piece, is greater than 85. So put it in terms of people in your class. That means 80% of your class got less than 85%, and therefore the remaining 20%, would have gotten a mark that's greater than 85%. Okay, so without further carrying on with discrete data, I want to quickly move on because I know we're going to run out of time. We've got so much to cover, Queen, so I'm not going to give you a chance to take a break. We're going to go straight into question 2 and deal with grouped data. Okay, so there we were looking at discrete, ungrouped data. Now we're looking at grouped data. We are given the mass in kilograms of 16 bodybuilders, and we are asked to calculate the estimated mean, estimated median, and the modal interval. Now, the reason we're dealing with estimates here, because we've got grouped data, it's going to result in a slight loss of information. In order to work out your mean, you're not going to be able to work out the exact point at which your mean is, and we use the class midpoints in order to find the mean. This then implies that you can only get an estimated mean, and then we can also only get an estimated median because your data has been grouped into these class intervals. Okay, so we've got what's called a frequency table. We've got the mass, we've got the frequency. Frequency is how often that certain interval numbers occur in that interval. We've got our mass of 150 and x, your mass is between 150 and 155. The frequency that happens with is 3. So in other words, 3 people have a mass between 150, let's say, kilos and 155 kilos. Okay, I'm going to dive straight into the first question, is to work out the estimated mean. Because we're dealing with grouped data, your mean is the sum of your frequency times the midpoint of your class interval divided by the total number of values. Okay, so it's the sum of the frequency of the interval times by the midpoint of that interval, and then that's all divided by the number of items we're dealing with. Now I've just included 2 more columns here because we need to put in our midpoint, okay? And then we need to work out a column for the sum of all of those values. So our midpoint, which we're going to call capital X, how do we work that out? You simply take the end points of your intervals and you divide by 2. So the first one is going to be 150 plus 155 divided by 2. Okay. And let's use our calculator. So it's 150 plus 155 divided by 2. That gives us 152,5. Can you do this all the way down the table? So first midpoint is 152.5. Okay, for the next one, I'm going to take 155 plus 60 and then divide that by 2. We'll just put our answers straight into our column there under midpoint. So it's 155 plus 160 divided by 2. And we get 157,5. Okay, let's just make that 2 a little bit more visible there. Okay, and then the third one is going to be 160 plus 165 divided by 2. That gives us 162,5. And then lastly, we've got 165 plus 170 divided by 2. 167,5. Okay, once you've got your midpoints for each of your intervals, you're now going to do a column where we add the sum of the, where we add up the product, of the frequency times the midpoint. Okay, so what we're doing here, so this column here, we're going to add everything together. Okay, but we'll do that at the end. For now, all we're doing is we're going to times the frequency by the midpoint. So I'm taking my midpoint, timesing it by the frequency, and putting the answer down there. Okay. So we've got, first one, 152.5 times 3. That gives us 457.5. Okay, your next one is going to be 157.5 times your frequency, which is 4, and that gives us 630. Okay, and then we've got 162.5 times 7, which gives us 1,137.5. And lastly, 167.5 times 2. So 335. All right, so we've times our frequency by our midpoints. Remember, why are we doing this? We need to work out the mean, which is the sum of the frequency times the midpoints divided by n, and n here is 16. So I'm now going to add all of those together, which will give me the sum of x times f. All right. Remember, guys, you can do all of this calculating on your calculator. You have statistic functions on your scientific calculator. If, however, you don't have a scientific calculator, although every one of you should do, then you can do it manually the way I'm doing it. But I want to show you the manual way so that you actually understand what you are doing and you're not just plugging random things into a calculator which just spews the answer out without any understanding. So we've got 25, the total 2560. Okay, so that's your total of the sum of your frequencies times your midpoint. And then in order to work out the mean, it's going to be that sum, 2560, divided by n, which is 16, the number of bodybuilders. So we take that, divide by 16, and we get an answer of 160. Okay, so therefore what that means is that the mean mass of the bodybuilders is 100 160 kilos. So on average, they weigh 160 kilos. All right, quickly, let's have a look at working out the estimated median. Now, your estimated median, again, because you're dealing with a class interval, you're going to use the midpoint of that interval for our median value. Okay, how do we work out what position the median is in? Well, we're dealing with 16 bodybuilders, so N is 16. So therefore, your median must be in position or between position. 16 is an even number, so between 8 and 9. Okay, so that's where your median value would lie. So we look at our frequency table and we have a look and see, well, where will the values of 8 and 9 lie? Where will the 8th and 9th data values lie? We can see in the first column we've got 3 and there we've got 4. So the cumulative frequency, if we add that, 3 and 4 is 7. Up to there, we've only dealt with 7 bodybuilders. So therefore, my 8th and 9th value will lie in this interval here. So therefore, my estimated median is going to be the midpoint of the third interval. So your estimated median is going to be 162.5 kilos. And lastly, your modal interval, that's your interval with the highest frequency. Okay, and we can see that the highest frequency is in the third interval, so our modal interval will be x is less than equal to 165 but greater than 160. All right, so we had a look at ungrouped data, we had a look at grouped data, and I know that all of you guys now know how to use your measures of central tendency and how to work them out when you're dealing with grouped and ungrouped data. Queen, definitely time for a break.
All right, but before we go to a break, mindsetters, in collaboration, as you guys know that we have Mathematics Mondays, in collaboration with our Mathematics Mondays, we've got this really, really cool MoMath app for you guys. It's a mobile application that you can join in order to test yourself on maths questions, and you can also see how well you are doing compared to our other mindsetters. This is a really cool mobile app, and I think that it is best for you guys to check it out. We'll be posting details on our Facebook page on how you can join this mobile math application and how you can get more information on it. So let's take a quick ad break for now, and don't go anywhere, because when we come back, we'll be announcing our Casio calculator winner. See you after the break. Welcome back, Mindsetters. We are still together on this grade 10 mathematics show. Now, this is the time where we are going to announce our Casio calculator winner. And the winner is, drumroll, Tato Kutumela. Congratulations, Tato. You've won yourself this really, really cool calculator, and it will be coming your way very soon. And if you've just joined us, do not despair. We've still got about 2 questions to go, right, Natasha?
Yes, all right, guys. So we've got 2 questions left to go, and we're going to try and fly through question 3. So I'm busy already putting the answer down for you guys so that we can look at the challenge question. Queen, do we have answers on the challenge question?
We have a few answers, but mindsetters are a bit quiet on this one, so I think it's really got their brains working.
All right, well, that's good. We like to get brains working on the show. Okay, guys, so question 3. It's basically a summary of everything we've done in today's lesson as far as our discrete data goes. We are asked to draw a box and whisker diagram to illustrate the 5-number summary. Now, the 5-number summary shows your key values, which are your minimums, your lower quartile, the median, the upper quartile, and the maximum values. All right, so that's your 5-number summary, and you then represent those values on your box and whisker diagram as they have asked us to do. Now, they've given us a whole list of values here, and if we count, we actually see that we have 15 values, okay? If I want the 5-number summary, remember I need the minimum value. Minimum value is 1, okay? That's where the data set starts, all right. We also need the lower quartile, the median, and the upper quartile. But before we can work out the lower quartile, and the upper quartile, we need to work out the median. Now, the median is this one in yellow. The median is the value that's right in the center of your data. So because you're dealing with 15 data values, okay, if you take 15 divided by 2, it will give you your position, which is 7.5. We round that up to 8. So in position 8 will be your median, and therefore our median value here is 15. Okay? To find your lower quartile, you take the lower half of values and you divide that into 2 equal pieces. So therefore you will see that your median of the lower half of values is 8. So that's our lower quartile. Do the same thing with the upper half, divide it into 2 equal pieces in order to get your upper quartile, and that gives us a value of 20. So your upper quartile is 20. All right, so I'm going to put all of this down on our little diagram that we've got going here. We want to draw a scaled line. Okay, mine is not drawn completely accurately, but obviously given time and that, you will draw this accurately for your test, and you will put down all of those 5 values. So we start with our little rectangular box where we're going to mark off the beginning, the lower quartile. So we're going to start at 8, and we see that it goes all the way up to our upper quartile, which is 20. All right, and I'm going to erase our median value there so that we can see our box more clearly. So we're going up to 20. We're starting from 8 with our little box, our rectangle. And then within that rectangular box, okay, we're going to mark off our median value, which is 15, and that's somewhere here, closer to the top of the box. All right, so we've got our lower quartile, we've got our upper quartile, we've got our median value. Then we extend the whiskers of that box to the minimum value and then to the maximum value, and we put little dots to include those values. So your minimum here is 1 and your maximum is 24. And guys, they ask you to explain what these values tell you, and I'm going to very quickly do an explanation here. What it tells us is that 25% of values lie between 1 and 8. All right? It also tells us that 25% of values lie between 8 and 15. Another 25% between 15 and 20, and then 25% of values between 20 and 24. In other words, 25% of values less than 8, 50% of values less than 15, and 75% of values less than 20. And then we've got what that would then imply is that 25% of your values are greater than 20. All right, so that's very quickly a summary of your box and whisker diagram and our 5-number summary. But I want to quickly look at our challenge question because, as Queen said, not everyone has gotten this answer as yet. Queen, but do we have some takers? Have some people tried?
Yes, we have some takers. For example, we've got Michi and Wandile, who both agree to, I think it's question A, they both agree that it should be equal to 9.
All right. Okay, guys, so let's have a look at what you've done here. Here we're dealing with mean marks. Remember, your mean is where you're going to take all of the values in your data set and you're going to divide it by the number of values in that data set. Okay, but the way it's phrased is what makes it a challenge question. Okay, Lesejo wants a mean mark of at least 70% for math. So she wants 70% for math, right? She writes 6 tests in total. So including maths, it's 6 tests. And she gets a mean mark of 61% for the first 5 tests. All right. They ask, what is the minimum mark she must get in the 6th test, being your maths test, in order to get an average value of 70% overall? All right, now let's put this into mathematical words, okay, or mathematical terms. She wants a mean mark of 70% for math. She writes 6 tests to get, and she gets 61% for the first 5 tests. In other words, How are they working out that 61% as your mean mark for the first 5 tests? Remember, you will add up the value that you have, or the marks that you have for each of those tests. This is how you would normally work out your mean mark. Divide that by 5, and that gives us an answer of 61%. Okay, that's just how you would normally work out, even in your test and exam situations. If you want to know what your average mark is, you take all of your tests divided by the number of tests, and you will get your overall percentage. Now, in the first case, when Lesego writes 5 tests, she gets 61% for the first 5 tests. Okay, therefore we can see that the total percentage for those tests, so from test 1 all the way to test 5, okay, so we're looking at that total, it's going to be 5 times 61%. Okay, so therefore her total there for all 5 tests is 305. Okay. Now, remember, she's writing 6 tests in total, including maths. All right? She wants to get a mean mark of 70% for maths, but she also wants to get 70% overall. Okay, so they're saying, what is the minimum mark she must get in the 6th test? So in other words, what is the minimum mark she needs to get for maths, really? That's what they say. So if I wanted to find the average of 6 tests, I'd add test 1, test 2, all the way to test 6. I would then divide that by 6, and I will get my mean percentage, which is 70%. All right? Now, what is the total for all 6 tests? All you're going to do there, cross multiply 6 by 70. We don't really need a calculator, but we will anyway. 420%. So she needs to get a total of 420% overall for all 6 tests in order to get a mean mark of 70%. What that implies is that for test 6, she will need to get 420% minus 305, which is what she got for the first 5 tests. So it's the total minus what she's already got will tell you what the remainder is, how much more she needs to get. So 420 minus 305, we get 115. So for that last test, test 6, she needs to get 115%. So we've answered part A. What is the minimum mark she must get in the 6th test to get an average of 70%? And we said that she needs to get 115%. Now, Queen, do you think that's possible, that she can get 115% in that very last test?
I don't think so.
Well, definitely not, because you can only get 100% for a test. Okay, so it's not going to be possible, answering part B. Based on your answer, will she be able to get 70% for the year? No, she will not, because in order to get 70% for the rest of the year, she needs 115% just in one test. That's not going to be possible at all. Okay, hopefully some of you got that. What are we getting comments on the page as?
Well, unfortunately, Natasha, we don't have any mindsetters that got the correct question, but it's okay, next time.
No, well, it was a tricky one this time, guys, but I hope what you should be getting out of this question really is how you can work with your mean, because remember, your mean includes all of your values, how you can work backwards to work out the total. Okay, that's what this question is showing you here. All right, I think with that, it's almost time to go, or do we have a question?
We have a question actually from Progress Rifumo, and he wants to know, I think it's based on the previous work, is it necessary to write all the numbers as scale in the Whisker diagram, or could he just include the necessary numbers?
Okay, so when we're looking at the box and Whisker diagram, this is the reason why. I mean, you don't have to write down 1, 2, 3, 4, 5, 6. You can use a more or less, sort of give an idea of where the values are on your number line. But it is important to give the accurate positioning on that number line, because if you don't, your data will not be a true reflection of the values that you have worked out for your 5-number summary. So for example, if I didn't use a scale and I said, okay, well, 8 is here, you know, it's going to completely skew what your box and whisker diagram looks like. So it is important for you to actually use it to scale or draw a scale when you're using your box and whisker diagram, definitely.
All right, progress. I hope you've got that. And we've been receiving some very good positive feedback from Priyashka and Katleho. They really, really love what you're doing, Natasha, and they think that you're like the best math teacher.
Thank you, guys. That really makes it worth it, and I really appreciate all of that comments as well. I hope that you guys have learned a lot, because remember, that's ultimately what we're here to do, is to make sure that you guys are learning. And I think with that, it is time to say cheers.
Well, you've heard it, guys, all from Natasha. And grade 10s, that is it for today with us over here. But don't worry, we'll see you again next week, Monday, same time, same place. That is all from me, and it is goodbye.